Hello everybody, welcome back to that cringy YouTube channel that I started 3 years ago, and then I abandoned. And I'm finally back to finish that 3-part series that I only made 2 videos of. So I hope you enjoy. I've seen a lot of you asking where the 3rd part is and why it's taking me so long. I don't have a good reason, really. I'm just kind of lazy and very forgetful. But here you go, I hope you enjoy. Alright, so atoms are the base for all matter, so it's pretty important to have a good understanding of them and the way they work. This video is the final part of a 3-part series which will cover all you need to know to have a good grasp of the atomic theory. This video being all about how to read the periodic table. The previous video explained all the parts and properties of an atom, and in this video we will go over how to see those properties in the periodic table as well as why the table is structured the way it is. First, let's learn how to read the little tile that each atom is represented by. Do keep in mind that the placement of these numbers and letters can vary from table to table, but they still mean the same thing. The big letter or group of letters in the center is the atom's chemical symbol. For example, hydrogen's chemical symbol is H. And right below that we have the element's name. Now this won't always show up, but it's very useful when the atom's name and symbol aren't exactly an obvious match. Take gold for instance, whose chemical symbol is AU. Next, we have the number in the top left corner. This is the atom's atomic number. If you remember from the last video, this is just how many protons the atom has. This is the number that separates each atom from each other. For example, hydrogen's atomic number is 1, while helium's is 2. And finally, we have the atomic mass at the bottom. This is not, however, the mass number from the previous video. Mass number is the number of protons and neutrons in a single atom. Atomic mass is the average mass of an element based on the abundance of that element's isotopes. Now I know that sounds really confusing, but we can use hydrogen as a really good example to demonstrate this. If you remember isotopes from the previous video, they are simply atoms of the same element with differing numbers of neutrons. Hydrogen, for example, has 3 naturally occurring isotopes: hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen 1 has only 1 proton and has a mass number of 1. Hydrogen 2 has 1 proton and 1 neutron. This makes its mass number 2. Hydrogen 3 has 1 proton and 2 neutrons to give it a mass number of 3. Now if we look at the abundance of these isotopes, we see that 99.98% of all naturally occurring hydrogen is the H1 isotope. Only 0.018% is the H2, and only 0.002% is H3. This makes the average mass of all the hydrogen atoms in the universe just slightly above 1, at 1.0079, or rounded up to 1.01. So the number at the bottom of each tile is the average mass of all the isotopes of a given element and how often they naturally occur. Okay, so now that we understand each tile, now we need to understand why they are placed the way they are. Well, they're obviously in order by atomic number. Hydrogen first, helium second, lithium third, and so on and so on. But why are they in this weird shape? Well, because we're looking at just the basics, it's much easier if you just ignore the whole bottom half and only focus on the first 18 elements. This keeps things from getting really complicated, plus these elements make up most of the matter in the universe anyway. Okay, so now that we have a simplified version of the periodic table, now we can see that the table is divided into rows. These are called periods. Each period has a different number of electron orbitals, or energy levels. The first period has 1, the second has 2, and the third has 3. But we can also see that it is divided into columns, called groups. These groups are separated by how many electrons they have in their outermost energy level. These are called the valence electrons. The first group has 1 electron in its outer shell, the second group has 2, the third has 3, and so on until you get to the last group with 8 electrons filling its outer shell. This is where there would be a huge exception to this rule if we were going to look at the rest of the periodic table, but this way is much simpler and easy to understand. However, there is one exception to this within the first 18 elements. I'm sure you've already noticed, but hydrogen and helium are weirdly placed on opposite ends of the table. This is because the first electron orbital can only hold 2 electrons, while the other 2 can each hold 8. This means that hydrogen still only has 1, so it goes in the first group. But, while helium only has 2, its outermost shell is completely full, so it goes in the last group. Now, we obviously ignored a huge chunk of the periodic table. but this keeps it simple and easy to understand while also encompassing the majority of all matter in the universe. There's a lot more to learn about the periodic table, and this is in no way everything there is to know, but it's just the basics. Thank you so much for watching this video that took me way too long to get around to making. If you did enjoy it, please subscribe, comment, like, everything you can do to hopefully motivate me to make another one. Who knows? I don't really have any ideas at the moment, but I've seen a lot of comments from people asking me where the other part is. I even saw someone say that one of my videos was used in their classroom. Somebody had their teacher tell them to watch the video and take notes, and it actually helped. So yeah, I hope this video helped you in some way, and I hope you have a great day.